Hi friends, welcome to GMK tutorials. In this video, we are going to see about the another type of a low pass filter, that is nothing but Gaussian low pass filter. Gaussian low pass filter. Gaussian low pass filter. Gaussian low pass filter. So the Gaussian filter, low pass filter transfer function can be represented as h of u comma v is equal to e power minus d square into u comma v by 2 sigma square. So where d of u comma v represents the distance from the center of the rectangle to the u comma v point, where d of u comma v is nothing but is equal to distance from the center of the rectangular. Moreover, suppose if the sigma is spread about the center, by letting sigma is, suppose if you are taking sigma is equal to d naught, the transfer function of the Gaussian low pass filter can be represented as h of u comma v, that is equal to e power minus d square u comma v by 2 d naught square. 2 d naught square. Where d naught is nothing but some positive constant. D naught is nothing but some positive constant. D naught is nothing but some positive constant. The characteristics of the Gaussian low pass filter. Gaussian low pass filter is also it is also some more very blur nature. This part can be represented as some blue color line. Here also same thing. Some light is a blue color. The remaining part can be represented as some white. So this is all nothing but a black color shades in case of the corresponding image. So this white space is, that means this white space is also somewhat blurriness in the image also. So this is just a graphical representation of the Butterworth low pass filter. It represents a U axis. It represents a V. That is nothing but columns. As well as the characteristics of the Butterworth filter can be represented as so this is nothing but h of u comma v. This is nothing but d of u comma v. The corresponding curves are maybe deviating like this. So this magnitude of the corresponding filter can be represented as 1.0. This is nothing but 0.6077. So this is for as the order of the filter, where this is nothing but d naught is equal to 10, d naught is equal to 20. So this is nothing but d naught is equal to 40. So this is nothing but d naught value is equal to some 100. So that means as the d naught value is increases, the corresponding graph may be shifted towards the right side, right? So that is one of the important observation, where d naught is also called as generally a cutoff frequency in all three low pass filters. Generally, that means d naught is also acts as some threshold value. Therefore, d naught is also called as a cutoff frequency. So d naught is also called as a cutoff frequency. When d of u comma v is equal to d naught means that Gaussian low pass filter is down to 0.607 of its maximum value. That means if the d naught value is equal to the d of u comma v, the maximum filter of the function is also equal to the, in this case it is equal to this value whenever the d naught is equal to d of u comma v, the value is equal to this case, this one, maximum 0.607 of its maximum. It is also generally we can call it a 3 dB gain of the filter. Okay, so this is a brief introduction about the Gaussian filter. One of the Gaussian filter advantage is nothing but if you are taking the Fourier transform of the Gaussian filter, it is also exhibits the same Fourier transform of the characteristics of the. So if you are taking the Fourier transform of Gaussian, it is also exhibits Fourier transform of the Gaussian pulse. So that is also one of the greatest advantage of the Gaussian filter. Moreover, this Gaussian filter is used in many applications in the pre-processing point of view. Okay, so this is a very just a brief introduction about the Gaussian low pass filter. Just okay, so just I can write the three filters, that is nothing but ideal low pass filter equations point of view. Just I have to represent equations for ideal low pass filter. So for ideal LPF, h of u comma v is equal to 1 for d of u comma v less than d naught, 0 for otherwise. Okay, so as well as for Butterworth filter, the transfer function is nothing but h of u comma v is equal to 1 by 1 plus d of u comma v by d naught into whole power 2n. So this is the order of the filter. As well as third one is nothing but Gaussian, that is also can be represented here, Gaussian LPF. So that is also nothing but h of u comma v is equal to e power minus d square u comma v by 2 d naught square. So these are the three important equations for this is for ideal low pass filter. So we generally in three cases this is generally called as a cutoff frequency. D naught is nothing but cutoff frequency and d of u comma v represents the distance from the u comma v to the center of the rectangle. So that is a very important consideration. So these three types of low pass filters, basic thing is nothing but which attenuates the low frequency component, that means which attenuates the high frequency. So the basic intention of these three filters means that attenuates high frequency. That is the basic nature of the low pass filter. Low pass filter means that which allows only low frequency and stops the high frequency. So this high pass one of the advantage of the ideal low pass filter and Butterworth low pass filter and Gaussian low pass filter means that which attenuates a high frequency means that the sharp edges in the images also smoothen, therefore it is also used as a smoothing purpose. Therefore in the frequency domain, image smoothing can be achieved with the help of a low pass filters. Okay, so thank you for watching GMK tutorial guys. Thank you.